All right. Adjacent arcs are arcs of the same circle that intersect at exactly one point. So arc RS and arc ST, since they only have point S in common, are considered adjacent arcs, arcs that are next to each other. Postulate 12.2.1, the arc addition postulate says the measure of an arc formed by two adjacent arcs is the sum of the measure of two arcs. In other words, arc ABC, these two arcs, is the sum of arc AB plus arc BC. And that makes sense that these two little arcs would form the big arc. Now, within a circle are congruent circles. Congruent arcs are two arcs that have the same measure. So if arc ST has a central angle measured of x degrees, then ST's arc measure is also x degrees. Likewise, UV's central angle is x degrees, so arc UV would measure x degrees. Since they're the same measure, arcs are congruent. So arc ST is congruent to arc UV. Theorem 12.2.2 has three parts to it, but it says in a circle or congruent circles, congruent central angles have congruent chords. So if these central angles are the same, so are chords CB and chords DE. Now that basically has to do with congruent triangles. EA is the same as AB because they're radius. Same with AD and AC. They're all four radii, which means they're the same. Of course, you've got congruent angles, like they said. That makes these triangles congruent by side angle side, so corresponding parts are the same. So if the central angles are the same, so are the chords. Second part says congruent chords are going to have congruent arcs. So if I know chord ED and chord CB are the same, then I know arc ED and arc CB are the same. Now, once again, being that these start the same, your radii are of course the same, all four of them. That makes these triangles congruent by side, side, side. Corresponding parts then are the same. The corresponding parts that matter to me is this angle to this angle. And if those angles are the same, then so are their corresponding arcs. And so if you have chords congruent, you have arcs congruent. And the third part says congruent arcs are going to have congruent central angles. So if we know these arcs are congruent, then we know these central angles are congruent. And that's basically simply easy by the definition that, remember, whatever the central angle was, so is the, whatever the arc is, so is the central angle. Whatever the arc is, so is the central angle. So obviously, if the arcs are the same, central angles are going to be the same simply by definition of a arcs arcs measure. And then the converse of this is also true, which means if you've got congruent chords, you got congruent central angles. If you've got congruent arcs, you've got congruent chords. And if you've got congruent central angles, you've got congruent arcs.